see. I'll keep an eye out on the chat if there's like shenanigans.
Okay. Okay, hi everyone. Welcome to week 3 of the Python DeCal. Today, me and Claire will be teaching more in depth about lists, dictionaries, and we'll also learn about recursion. Okay, so first for some announcements. The first homework was due just now. You guys should have all submitted your Jupyter notebooks to B courses. Homework 2 will be released later today. It'll also be due same time next Wednesday at 3 p.m. And then, as you know, we have a bunch of office hours, so a lot of people have been coming in for homework help, and so just continue doing that for all the homeworks in the future. Okay, and we also posted a demo for today's lecture, so if you guys could download that. I sent an announcement about it earlier. And we also have some guides on some Python how-to, so you guys can also check that out in the resources folder. Okay, so for a quick recap from last lecture, Isla talked about Boolean statements. So these are some statements that return either true or false. So for an example, if we have false and 1 equals 2, this statement would be false. So we know that for the word and, if there's one false statement, the whole statement will be false. And for or, if there's one true statement, the whole statement will be true. We also talked about if statements. So if you have the word if followed by a Boolean statement, if the Boolean statement evaluates to true, you'll then execute any code that's inside of your if statement. And then we also began talking about for and while loops, and today we'll be going over those again. Okay, so for a while loop, let me move this. So a while loop, you use it when you want something to happen as long as the condition is met. So you can just repeatedly keep going in a loop, and anything that is indented in your block, you'll just keep iterating and going over the same loop. So if you look at the basic structure for a while loop, you first start with your keyword while. You have to make sure that you do an undercase or lowercase w, followed by your Boolean statement, and then a colon. So all of these you have to include, otherwise the computer won't recognize it as a while loop. And then it's also important to note here that this is kind of just some pseudocode to tell you the structure, but notice that everything we have under the while loop is indented by one tab. And so that's how the computer knows that this is the chunk of code that I want to execute whenever I do a while loop.
Just keep in mind for the syntax, that needs to be an exact match. So a tab is a tab, or I guess 4 spaces, but also, keep it simple. That's important. There are some people who are having issues because either didn't close a parenthesis somewhere, didn't fully indent, whatever. Those are common reasons why you might be seeing errors or your stuff isn't running. Just be aware of it.
Yeah, so for a while loop, it'll just keep executing everything inside of your loop until the Boolean statement at the top where you defined your while loop becomes false. So it's really important that we have this line here that something will change each time. Otherwise, your while loop will keep going forever because it never knows when to stop. Okay, and then for a for loop, similarly, we can iterate and do a chunk of code a bunch of times. So the difference here is that usually when you use a for loop, you're iterating over some sort of list or tuple. So you already have like a set, like this many things, do something for each of them. And similarly, we have the same syntax of you have to do a for loop. You can define any name here, and then you can do in. And this is usually a list or a tuple of some sort, so a bunch of things in a list. And we have our colon, and similarly, you need to indent any blocks of code you want to put in your for loop. Okay. Yeah, so now we'll be continuing the demo that we didn't get to finish last time, and we'll be able to review some of this stuff. So let me pull that up. All right. Oops, it's down here.
Yeah, so when you guys are coding loops and stuff, just a couple common things to watch out for. Like Emily said, sometimes you might end up with an infinite loop, or alternatively, your loop stops too early, doesn't run through all the cases you would like it to run through. So always make sure to check how and where you're changing whatever variable you are using to essentially track how many times you're going through this loop, how many times you're iterating, right? And keep in mind where you're starting, where you're ending. I think that'll be like pretty clear when you start playing with some examples, but just good thing to be thinking about, like, are we getting closer to our end condition, right? Like, how are we changing things? It's a good thing to keep in mind for anything like this.
Okay, so this was the demo that Isla started last time. And so here we're basically going to create a die simulator. So if you roll a dice, it'll land like on a number 1 through 6. And so with this simulator, we want to basically create a game where if we input a number and it's also what we rolled on the dice, it'll tell us it's correct. And otherwise, it'll tell us to try again. So since this is coming from last time, I'll just walk through it quickly. So we have our while loop here. And so while our guess does not equal the current dice value, so while we haven't guessed the dice correctly, we want to keep guessing, basically. And once we do guess correctly, it'll break out of this loop. So first, we'll see that we input, this is just kind of a line so that we can input a guess in, which will just be like a number. And so now we want to check. So if the number isn't a valid input, so if it's not a number between 1 and 6, so we need to check that it is between 1 and 6 so we can check that it is a valid input. So if you remember with Boolean statements, we can do this by checking that guess is less than or equal to 6 and guess is greater than or equal to 1, since this will be all the numbers 1, 2, 3, 4, 5, 6. So if that is true, okay, so so actually we'll just do like, so to check if it's a valid input, since we want the rest of the code to execute if the input is valid, we'll kind of have our if statement filter out any inputs that are not valid. So instead of kind of validating the check like this, we can check that it's not true. So we can add a not here. So we can see that if it is not a valid input, we want to kind of not do any of the stuff below. So we can add a continue here. And this is a keyword in Python so that it'll continue in the loop and not do any of the code below here. And then we can print something like invalid input. So now if we continue with the code and we do guess the dice correctly, we'll want to print something like congrats. The guess was correct, or whatever we want to write. And then if in the other case that the value does not equal to the guess, we want to say something like try again. Okay, so now if we try to guess the value of the die, yes.
Does it matter if we have this guess equals the value or if value?
Yeah, so that's a good question. He asked, does it matter if we do value equals guess versus guess equals value? And so those are both the same, since it's just a Boolean statement and it doesn't really matter the order. So yeah, we could also have done guess equals value. Okay, so let's see if I guess like 2 or, oops. So you can see I got this error that name random is not defined. And I can kind of guess that, oh, maybe I didn't run this thing that says random. So let me just run that. And now it should be good. Okay, so it wasn't correct. So try again. I'll guess some other numbers. And we can try doing an invalid input. So we do like 7 and it'll print like invalid input. Okay, so I finally got the correct guess. So you can see that this bit of code is kind of doing what we want it to do. Okay, and so for the other example from the demo, this is just a simple function so that we can kind of calculate the integral of a function manually. So as you guys know, with like integration, you kind of have two bounds, like a starting bound and an ending bound, and you want to sum up for every dx interval, like the kind of height of the function or the value of the function. So if we go to our code, here we can see that we want to assign x to where our integration start point is. And from this comment here, so a lot of times functions will have comments that will tell you what the function is doing. They don't actually affect the code in any way. So since this is just a string, it won't make any difference whatever we put in here. But this is just good practice to have to let other people know what this function is doing. So we can see here that we want to integrate this function between bounds A and B. So we can see that A should be our starting bound. So we can assign x to be our starting bound. And so basically we want to keep integrating from A until B. And then once we get beyond the bound of B, we want to stop. So to write our while loop, we can do something like while x is less than B. And we see here that this loop will eventually terminate because in our code, we also have this x plus equals to dx. So x will increment by dx every time. And this line of code is also equal to this. Doing the plus equals like this is just kind of a shorthand that a lot of people do when they're coding. So now that we kind of set the bounds for our integration, now we have to do the actual integrating part. And we can see here in the code that this line seems to be where we should add to our value. So value starts at 0, and so every time we integrate dx, we want to add the dx times f of x value to the value. So here we can just do y times dx. Since here y is our function, and we're just multiplying by the little dx that we were doing. So now if we run this, we'll be able to integrate the rectangle from the start and end bounds. Okay, does anyone have any questions on the demo from last lecture?
Yes.
I guess it is more a math question. We're not considering the D, like the end term. Is that because we're starting from, like calculating from A, and so we don't consider B because like has to be the inside area or something like that?
Yeah, exactly. And also since we are adding it like at the end, kind of, we do take into that dx already.
Kind of like naming sums, right? So you have something here, right? Whatever. Like you start out with A here, and this is something like you're going to be here, right? So like B is here. So this is sort of like the last rectangle that we read.
Yeah, and so in our while loop, the last like value plus equals y times dx, we'll take into account that last bit. So yeah. Okay. Okay. Okay, yeah, so now for today's lecture, we're going to start with kind of more of a letting you guys write some of your own code. So for an activity for like everyone to work together for about 5 minutes, try to write the function factorial. And so as you guys know, a factorial is basically, if you have like factorial of 5, you would return like 5 times 4 times 3 times 2 times 1. And so a good way to do this would be using a for loop or a while loop, whichever one you guys prefer. And so yeah, like factorial of 3 should be 6. And if you're using a for loop, you can try using this line here, like for blank in range blank. That'll let you loop over a range of numbers. Yeah, so feel free to talk with the people around you, and we'll give you guys like 5 minutes to try to figure this out.
Wait for them to get started with it.
Yeah.
If it's starting at 0 times anything.
Oh yeah. I think a lot of
play with the
people did that
range
last
of it.
semester.
Well, I think it's just easier to is it the same as this? Yeah, I do that. I've got a laptop that just doesn't have enough room for Python. Yeah, it's pretty yikes. So I've got a desktop back in my room, but I feel like half of this is just conceptualizing anyways. I have a great idea, but then I forgot to add a variable. Result is a great variable.
So what are you thinking of initializing? Yeah, okay, that's a good. Yeah, that's good. Like people often do zero, but then they forget more, or we shouldn't do zero times anything, because zero. So yeah, definitely do more. As a
So then, like,
yeah, that's really good. So I think maybe just test running it a bit in yours, but yeah, I feel like it's good so far.
I had an idea, and then when I ended up with zero, because this, the last number takes this to zero. So I'm thinking instead of
Do you have class or is it just? I'm sorry, so many people. It's like,
yeah, so
I'm
it's
sorry.
just the last number, then
Last
every
number
like,
with an N?
like 5 times.
No, it's like a mix something.
Yeah.
It'd be difficult. So many names.
no, so that's why
And then I will also make a
I'm setting a variable. I wanted to ask because I forgot how factorials work. I was just gonna say no negative number.
You can say if x is less than 0, print wrong bad. Let's say only greater than 0. And then we can do did not come out paper.
So why? Because my range was
Or return result. This is the actual for x, whatever x is, let's say, result time.
But I don't know. Now I'm
Okay, so it looks like everyone's gotten started on the problem, so we'll go over it now. If everyone could kind of redirect to the board. Okay. Ugh. Okay, so does anyone have any ideas on how to start writing factorial? I saw a lot of people had good starting points, so if someone could share one of those. Yes. Oh, sorry, can you say that again?
Total equals 1 and then y x total times equals x times 1.
Okay, yeah, I think that's a really good start with first defining a variable that's kind of will keep track of our factorial value, and he said set that equal to 1. So here I'll just write like product equals 1. And then he also suggested using a while loop and kind of keeping track of while some number is less than the x value that we're passing into our factorial. So we can also initialize a counter for that, and I'll just call it I. Okay, so while like I is less than x, we can then start multiplying our product by each value of x in a way, or yeah, or actually I think maybe it makes sense to go backwards in it, since when we do a factorial, right, we do 5 and then times 4 times 3 times 2 times 1. So I saw a lot of people were incrementing up. Well, let's just increment down to kind of keep that pattern. So I'll just set my I equal to x, and then we'll say like while I is greater than 0.
To be clear, both methods work. Just make sure that with whatever way you're doing it, your beginning and end points are consistent with what you're trying to do, right?
Okay, yeah, so and then the suggestion was to, so now that we're in our while loop, and this will basically iterate a few times until we get to 0. So basically it'll do it x times. Every time we want to take our product value that we have here and multiply it by x. And then we can multiply by I, and then here we can just, we need to decrement I, since we need to make sure we are changing the condition in our while loop, so eventually it'll be false. So it's really important that we are subtracting 1 from I each time, because then eventually this will become false and we'll be able to access this return statement. So now we can just return product. And also with these lines of code, we could have also written something like product times equal I, since those are equivalent. Okay, so now if we do factorial 5, we see we have 120. And so in the discussion activity, we also said you could have used a for loop to write this. So I'll also show you guys how to do it with like a for loop. So if we want to do range, we could do like for I in range. And so we want to basically multiply by every number 1, 2, 3, 4, 5, including the x value. So the first lower bound of our range is inclusive. So we can start that at 1. And since the upper bound is exclusive, instead of doing x, we would need to do x plus 1, since this will give us the range of like 1, 2, 3, 4, 5. And so now we can similarly do here, we need to define product. And then we can do product times equals I. And so you can kind of see the difference between a while loop and a for loop. In a while loop, you have to kind of make sure you're changing the Boolean statement each time. But for a for loop, since it's already a defined set of numbers you're iterating over, we don't need to do this. Okay, and so this is also the same code. Okay, does anyone have any questions about this factorial stuff? Yes. Yeah, so it's a cool shortcut to do if you just highlight over your chunk of code. On Mac, it's doing command and then slash, like the slash under the question mark. You can, and it goes both ways, so you can comment and uncomment really easily. So Windows, it's probably control and that slashy thing. But yeah, so that's really helpful to do. And so what these hashtags mean is that this code is basically like a string. It won't affect any of like the code in the cell. Okay. Okay, and so moving on to what we want to go more in depth for today is that we already learned a lot about lists and dictionaries, but we're just going to go more in depth on these and how you would actually use them. And so we've already seen before that lists are basically represented by these brackets, and you can have some data inside. The data can be any type, so you can have strings inside, numbers inside, you can have other lists inside, and even functions. And these are basically used when you want to keep track of data as a group. So instead of defining 5 different variables for like 5 different people's names, I can just label all the instructors as instructors and then have a list of them. This is just so it's a lot more organized. And if you want to do something to this entire group, it's a lot easier to do. And it's also important to know that a list is ordered. So any time you want to get the first element of this list, it'll always be Emily, and the last element will always be Isla, unless you add stuff to your list. Yeah, and so now I'll just show you in the demo some like how to code with lists. Okay, so let's say I wanted to create a list. I would just do like animals equals empty bracket, and this will just create an empty list. So if we see here, if we print animals, this will just show us this empty bracket. So now let's say I wanted to add an animal to the list. So let's say I wanted to do like, I want to add cow to the list. Lists have this built-in function that's really cool called append. That'll just add something to the end of your list. So if I want to do animals append cow, you can see that this will now add the cow to the list. Similarly, if I do it again, or maybe like dog. Ew. Okay, since it ran the cell twice, it appended another cow and then appended dog. So it's kind of important to remember when you're running Jupyter notebooks that it kind of keeps track of everything you ran before, even if you change that cell. Okay, and another way we can add something to the list is using the addition operator. So we could do something like animals plus equals. Okay, does someone want to give me another animal to add to the list? Beaver. Okay, so you can just write it like this, and you should note that since we're adding something to the list, this element in here also needs to be in brackets because it's basically saying we're combining the two lists together. Okay, so now if I print animals, I get cow, cow, dog, beaver. So let's see what happens if we don't have these brackets, for example. You can see it does a lot of weird stuff. It added every single letter to our list. So if you see that, you probably know like, okay, I need the brackets. So let's just keep those there. Okay, yeah, and so I guess this, I left the comment there, but yeah, just showing you that plus equals is the same. So here I could have also done animals plus beaver, and these are equivalent. Also note here, we didn't need an equal sign. We could just do append. But doing any of these three are the same. It's kind of more up to you and what is easiest for you to remember. Okay, so now let's say we wanted to remove an element from the list. I think a lot of you wanted to do this on last week's homework, but you didn't really know how to. So we can just do animals.remove, and then you have to state what element you would actually like to remove. So let's remove dog. So now you can see my animal list is like this. It just removed the element dog. Okay. Oops. And you can see since I ran this again, but there was no dog in the list now, if I try to remove dog, I'll actually get an error because the computer is like, there's no dog in the list. I don't know how to remove that. So another way we could have done this though is instead of doing this remove, so let's say you forgot remove, you could also just do it with a for loop. So you could say like for animal and animals, and do like if animal equals cow. Or here, we can kind of copy our list like animal copy equals empty bracket. So to basically remove cow from the list, we can just make another list, but don't include cow. So if animal is equal to cow, we don't want to include it in the list, so we can do continue. But otherwise, we will add it to animal copy.
Creates a whole new separate list.
Yeah, so now if we look at animal copy, we have the same list, just no cows. Okay, and so like I said before, we can also put lists inside of lists. So let's say I want to make a list like organisms. I can make this a list of animals. Let's say I also want to have some plants on the list. I can add like a plant here. And then if you look at the list, organisms is now one list of animals and one list of plants. Yes, question. Yeah. Yes. Like just yes. So if we wanted to do that, there's a few different ways. You could, instead of doing continue here, you can do break. So basically after it gets to, actually not break, sorry, if, so I don't know if there's a super elegant way, but definitely I think the way that you would do it, and a lot of times code just isn't that elegant, you could define a variable. So like you could say like removed beaver equals false.
You could also read through every element in your list with a while loop. So you can say like while the thing I'm currently looking at is not beaver, then add it to a list.
Yeah,
and in that case when it encounters the first one,
Yeah, then I won't copy the rest of it though. So yeah, okay, so yeah, you could do like something like a Boolean, so remove beaver equals false. And so then after you do remove the beaver, you can then have removed beaver equals true. And then you can kind of add another statement here. So if you already removed the beaver, continue, or else. So yeah, instead of having, or this should be here actually. So if you did remove the beaver and you want to add this one, you can kind of append it. Yes, so not necessarily super elegant way, but you could definitely do it by defining more variables, and that kind of is how the coding process works. The more things you want to do, the more variables you'll need, and the more steps you'll kind of need as well. Yes, this should work. Yeah, so now let's say we are back to our organisms list and we want to index into them. Like let's say we wanted to look at the first plant in the list. So we could do organisms of, so if we did organisms of 0, Python is 0 index. So this will just return us the entire animal list. So you see here, organism 0 will give us the entire animal list, since that's basically the first element in our organisms list. But if I do organisms of 1, this will give us the first plant. And then let's say there were, okay, yes, but it'll give us the plant list. So now let's say we actually wanted just the cactus and not the list. We could go further and do another index, and this will just give us cactus. So you can kind of stack your indexing so it'll go further and further into your list. Okay, does anyone have any questions about lists and how you can use them? Yes. Oh, okay, yes. And so quickly now for dictionaries, we can kind of similarly create a dictionary. These we talked about earlier are basically just keys and values. So when you access your key, you'll then get your value. And so we can just manually add things to our dictionary by say doing like, so if we see here, this will create an empty dictionary, and then it'll give us one key value pair of Earth is 24, an Earth day is 24 hours. And similarly, if we wanted to create this dictionary from the list we already have, we could have done dict of planet day hours. And I can see here, this will give us our whole dictionary, since we just created a dictionary from this list we already had. And this is cool because if we want to look up like Mercury, we could do code like this, and this will give us Mercury. And so for now, we'll kind of skip the writing code to compare the ratio, but I'll show you how to delete some keys from your dictionary. You can just do del planet days of the key you want to do. And so if you look here, this basically deletes the Pluto key from your dictionary. Yes. So this is a quick overlook at dictionaries and basically just adding and removing stuff from them. Okay, so now Claire will start talking about recursion. We'll probably go into next lecture as well, but maybe just an intro for now.
Yeah, so recursion, FYI, is a pretty big topic. It's pretty important, comes up a lot if you're doing a lot of coding. I am aware that it's a bit complex. Might take some time getting used to, but that's perfectly fine. If we can't finish it today, we'll continue next time. But just like a little bit of an introduction. So if you've heard of it before, it might seem a little bit intimidating, but the whole concept behind recursion is actually not that complex if you think about it. So at the very, like the gist of it is literally just, you have a big problem, right? Maybe it's a like pretty intimidating problem with a lot of steps. You don't really know how to start. But a good way you can try to tackle this big problem is by breaking it down into similar, smaller problems. So, for example, we talked about factorials earlier, right? You could say, oh, 5 factorial, that's 5 times 4 times 3 times 2 times 1. Or that's 5 times 4 factorial, which is 4 times 3 factorial, etc., right? It's like you're taking this big problem, 5 factorial, and breaking it down to a smaller problem, 5 times 4 factorial, and you continue breaking it down. So that's like the big concept behind how recursion works. So basically, yeah, you're breaking a problem down into similar, smaller problems until you have a sort of base unit that you can operate on and be able to use that to solve your whole bigger problem. In code, the way we can do that is we can call a function repeatedly. We can call a function on itself repeatedly with maybe slightly different inputs to make it do what you want at the end. So for example, if we thought about this, right? It's like similar chunks all the way down, right? Each one of these is a similar unit. You keep breaking it down into a smaller, 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 smaller problem. That's like the gist of how recursion works here. Similarly, if you look at this, it's like definitely not a Triforce from Legend of Zelda, but you know, like each one of these little triangles here is a unit. It's like the same unit, right, as the bigger piece, just on a smaller scale, and it's the same thing all the way down. You can think of it like that, right? A big problem broken into smaller parts that are all similar, so you can basically like keep doing the same thing to it over and over until you get to a base case. So yeah. So yeah, you might be wondering, okay, how do we implement something like this in code? So the biggest thing here that might be a little bit of a jump, it might be pretty new, is something called the recursive leap of faith. So what this idea basically just means is that when you're trying to solve a problem with recursion, right, when you're breaking a problem down into smaller problems, assume that when you call the function recursively like this, when you call the factorial function within factorial, trust that whatever this sort of sub call does is going to eventually meet the base case. Pretend or imagine that it's going to do what you want it to do, right? For example, 5 factorial equals 5 times 4 factorial. We'll assume that 4 factorial gives us whatever answer we're looking for, right? It gives the right answer. And then 4 times 3 factorial gives the right answer, etc. So the way this works then is you don't have to think too much about like what exactly is happening in that recursive call. You can just think that, okay, it'll give us whatever answer we're looking for. In that case, if we assume that this call gives us the right answer, what do we do to it to get to the next answer, right? So for example, if we know, okay, 5 factorial is 5 times 4 factorial, we assume that 4 factorial works with the recursive leap of faith, then all we need to do is multiply that by 5 to get our answer, right? Pretty simple. So essentially that's what this piece of code is doing right here. We make this assumption, we operate on, you know, the result from a recursive call. The important thing though is that eventually, whatever you change this parameter that's being passed to the recursive call is, that needs to get back down to our base case. And like the way you can think about the base case is it's the simplest possible case of this problem, right? Like the simplest factorial you can do, I don't know, 1 factorial, that's 1, right? That's like pretty straightforward. That's like, or 0 factorial if you want, but that's like as simple as you can go, right? In that case, then our base case would be this basic, super simple case, n equals 1, right? 1 factorial. And then if we have an n of n equals 2, well, okay, that's 2 times 1 factorial. If we have 3, okay, that's 3 times 2 factorial, which is 3 times 2 times 1 factorial, right? And you just, like, that's what I mean by when you break down a problem into smaller pieces and sort of like work backwards, right? Operating on those pieces to get you your final answer. Does that kind of make sense? Like, let me know if you guys have any questions, because I know this is a lot. Sounds good? Okay. Honestly, this kind of thing, you do some coding practice, it'll make a lot more sense. But I hope like the general idea of how to approach problems like this is starting to coalesce a bit. Yeah. So yeah, like we saw in the previous example, your recursive case is that function. It's like, if you're not at the base case, what do, right? Your base case is n equals 1. If you're not at n equals 1, well, you call the function again, recursively, recursive call. You change your argument a little bit, like we were doing there, right? We went from n to n minus 1, which will be that n minus 1 again, etc., all the way down until we hit n equals 1, the base case. So yeah, make sure you're modifying your arguments a little bit each time to move it towards the base case. You can think of this as pretty similar to your loops, right? you're doing a while loop, well, you need to increment whatever or modify whatever you're using to track the state of your loop, right? Otherwise, you'll get an infinite loop. Same with this. If you don't modify anything, you might get infinite recursion, which sucks ass. It crashed my computer once. Would not recommend. Yeah, but basically, it's the same idea with iteration, really. You're breaking down a problem and going until you hit some end case. So, like we said, base case is the end of that really long chain. When you hit the base case, it tells you, okay, we're done with the recursion. We take whatever result this base case is and sort of pass it up through all the steps that we got from, doing those recursive calls, right? And that's our end result. So you can, the way to think about it is when your function is at its smallest value or at its like most simple case. And of course, we got a meme here. If you Google recursion on Google, it will send you to a page that says, "Did you mean what is recursion?" So, fun little aside, a little bit of a joke, but yeah, it's all the way down. Anyways, I don't know how much. Okay, I can maybe speed run one more slide. But yeah, like this is similar. This is the same code we saw earlier, but as you can see, you can see that process of breaking down the problem, right? Like you start with, okay, the first time, right? N equals 5. Is it 1? No, it's not. So we go to the recursive case. 5 times, call factorial on 5 minus 1 equals 4. Is 4 equal to 1? No. So we keep going. Then we pass in n minus 1. 4 equals 4 minus 1 equals 3 to the function call. Do it again, and we track by doing these recursive calls, we're basically tracking what that n is. It's changing every time. So by the end we get down to n equals 1, then we sort of pass that 1 up through these recursive calls, right? So you do 1 times 2, times 3, times 4, times 5, all the way you get through all of your function calls, right? Does that make sense? I'd recommend you play around with stuff like this a bit. There's also, we can pass this a bit. So you might be asking, okay, this sounds kind of complex. Why the heck would we ever want to use recursion? And the answer to that is, recursion is definitely not the best way to solve every single kind of problem, but in some cases it'll definitely help a lot. There's some problems that are pretty easily expressed as, smaller steps, like pieces of smaller pieces of a bigger problem. They all are sort of a similar thing all the way down, right? So that recursion lets you express that really easily in code in a way that makes, quite a lot of sense. If you play around with it, you'll notice that there's some problems that make sense in iteration that don't really make sense to do recursively, and vice versa. There's something called tree recursion, which lets you express multiple possible paths. So for example, there's a pretty, common intro CS problem that goes, oh, you have a number of stairs, and you can take either 1 step or 2 steps at a time. How many ways are there to get to the top? And you can think of it as a branch, right? Okay, I start at the bottom. I take 1 step. How many steps do I have left? I take 2 steps. How many steps do I have left? What if I take another step? What if I take 2 steps? What if I take 1 step? What if I take 2 steps? Et cetera, et cetera, et cetera, et cetera, et cetera, et cetera, all the way. Yeah. So that's tree recursion might get a little bit complex, but that's the idea of what you can do with this tool, right? With this way of approaching problems. If you do it right, and if you find a problem where this is a good way to solve it, it can definitely make your code super clean and super efficient, right? You saw that factorial thing, you look at it, it makes quite a lot of sense, right? Multiply it all the way down until you hit 1. That's pretty straightforward, right? I don't know how much time we have, but we can do a super quick example of if we can't get to this, it's another thing that you can sort of think about. How many of you guys here are familiar with the Fibonacci numbers? Yeah, and the way those are defined, right? It's the previous Fibonacci number plus the Fibonacci number before that gives you the next one, right? And this is a pretty good example of a problem you can solve with recursion, right? Because if you consider every Fibonacci number is calculated with the same way, relying on the previous ones, you can just recursively call a function that generates those numbers, add them up, and in the end you'll have Fibonacci n minus 1 and Fibonacci n minus 2, add them, and you get your result. So if you wanted to do it in code, it would look something like this. I'd encourage you guys to think through it, see if the process makes sense, right? Think about how you would calculate Fibonacci's by hand if you were given like the first 5 Fibonacci numbers, or even the first 2, right? It's that same process, but instead of you doing it, Python's doing it for you. Isn't that awesome? Yeah.
Okay, yeah, so that's it for today, and we'll see all of you next week on Monday.
Yeah. See y'all. Oh my god. Bro. I'm like
Bye, Julia.
so much too late on.
Bye.
Well, like, is it a